Mean opinion score is a test that has been used for decades in telephony networks to obtain the human user's view of the quality of the network. Historically, and implied by the word opinion in its name, MOS was a subjective measurement where listeners would sit in a quiet room, and score call quality as they perceived it. Per ITUT recommendation pages 800, the talker should be seated in a quiet room with volume between 30 and 120 m3 and a reverberation time less than 500 milliseconds. The room noise level must be below 30 dB with no dominant peaks in the spectrum. Measuring voice over IP is more objective, and is instead a calculation based on performance of the IP network over which it is carried. The calculation is defined in the ITUT PESQ pages 862 standard. Like most standards, the implementation is somewhat open to interpretation by the equipment or software manufacturer. Moreover, due to technological progress of phone manufacturers, a calculated MOS of 3.9 on a VoIP network may actually sound better than the formerly subjective score of greater than 4.0. In multimedia, especially when codecs are used to compress the bandwidth requirement, the MOS provides a numerical indication of the perceived quality from the user's perspective of received media after compression and/or transmission. The MOS is expressed as a single number in the range 1 to 5, where 1 is lowest perceived audio quality, and 5 is the highest perceived audio quality measurement. MOS tests for voice are specified by ITUT recommendation pages 800. The MOS is generated by averaging the results of a set of standard, subjective tests where a number of listeners rate the heard audio quality of test sentences read aloud by both male and female speakers over the communications medium being tested. A listener is required to give each sentence a rating using the following rating scheme. The MOS is the arithmetic mean of all the individual scores, and can range from 1 to 5. Compressor-decompressor systems and digital signal processing are commonly used in voice communications, and can be configured to conserve bandwidth, but there is a trade-off between voice quality and bandwidth conservation. The best codecs provide the most bandwidth conservation while producing the least degradation of voice quality. Bandwidth can be measured quantitatively, but voice quality requires human interpretation, although estimates of voice quality can be made by automatic test systems. A similar process can be used to evaluate subjective video quality. As an example, the following are mean opinion scores for one implementation of different codecs. One consideration when planning a VoIP deployment is the bandwidth usage for a particular codec versus the potential MOS. For example, G711, with a sample size of 64 kbits, achieves a maximum MOS of 4.1, whereas G729, with a much smaller sample size of 8 kbits, can achieve a MOS of 3.9. G729 is compressed 8 times smaller than G711 while sounding almost as good. A drawback of obtaining MOS estimations is that it may be more time-consuming and expensive as it requires hiring experts to make estimations. When a voice coding system is under development, or the developer has to test and compare a couple of audio systems, it's very important to have a possibility for a quick check. Some suitable English language phrases used for determining a MOS as suggested by ITUT recommendation pages 800 are, "You will have to be very quiet. There was nothing to be seen. They worshipped wooden idols. I want a minute with the inspector. Did he need any money?" There exist some analytical formulas to estimate the MOS from packet losses in percentage and the packet's duration in miss. Predicted MOS equals 4.0 minus 0.7 ln, percent loss, 0.1 ln, size miss. See also, subjective video quality, MUSHRA ITUBS 1534 recommendation, PSQM perceptual speech quality measure, PESQ perceptual evaluation of speech quality, is mechanism for automated assessment of the speech quality enjoyed by the user of a telephone system. It is standardized as ITUT recommendation pages 862. POLQA perceptual objective listening quality assessment, is replacing PESQ. It is standardized as ITUT recommendation pages 863. PEVQ Perceptual Evaluation of Video Quality, a measurement algorithm for the automated assessment of video quality. PEAQ Perceptual Evaluation of Audio Quality, a measurement algorithm for the automated assessment of audio quality. Absolute Category Rating, MNRU, references. External links, ITUT recommendation pages 800 Methods for Subjective Determination of Transmission Quality, Voice Quality, Aqua, Audio Quality Analyzer, NIQA Non-Intrusive Quality Analyzer, Impact of Network Performance Parameters on the End-to-End Perceived Speech Quality, E-Model.